I want to do a quick video on Vsepr theory. It's Vsepr, but people say Vsepr. It stands for valence shell electron pair repulsion theory. And it is what it says it is. Essentially, it's just a theory on shapes, and basically, all you have to do is just know that electrons repel each other. So all electrons, all bonds, want to get as far away from each other as possible. So there are a lot of different shapes. There's even more than the ones that I'll talk about. But a couple of them I just want to go through. I'll show you examples in another set of videos. But there are, let me see here, 9 shapes I think you'll be responsible for in my class. The first one being linear. Okay, linear means you have a central atom, and then you have atoms on either side of it. Okay, that would be a linear shape. And this is going to happen when you have one atom bonded to 2 other things, and there's no electron pairs in the middle to kind of move the bonds around. If you look at something like water, okay, water has 2 things bonded to oxygen. The problem is when we actually draw out the molecule here, notice it has electron pairs here, and those pairs are going to push the bonds down instead of allowing it to be straight. And so that would be an example actually of a bent molecule. So something like this, that is bent. And the reason it's bent is because of the electron pairs. The next one, let's say trigonal planar. Alright, trigonal planar is when you have 3 things bonded to something, and it's going to make sort of a perfect triangle there, okay? Each of those angles being about 120 degrees. And that's going to be on a molecule where you either have no electron pairs in the middle to push them one way or the other, or you're going to have a set of electron pairs on the top and the bottom that push equally so that they'll all line up along the equator. So if you're looking at this along the equator, you'd see kind of like this and then one behind. It would be straight. Alright, now if you did have electron pairs, an example of that would be ammonia. Okay, NH3, well, nitrogen has electron pairs, and then you would bond to the hydrogens. It actually pushes them down. There's a way to show this where we actually use dashes and triangles. I typically do the dashes going back and then the triangles coming forward. And that is basically showing you that it's a tripod. So this one right here is going back into the page. This one right here is coming out of the page. And then this one right here is in the page. But see, this electron pair is actually pushing down on the bonds to make that little tripod type of deal. And that is what we called, that's what we call trigonal pyramidal. Trigonal pyramidal. And then this one right here would be your trigonal planar. Trigonal planar. So if this one had angles of 120 degrees, that means that the trigonal pyramidal has to be less than 120. Typically, it's somewhere around about 109.5-ish, but it's going to be less than 120 because it's going to be pushing down. So we talked about linear, trigonal planar, bent, pyramidal. Next would be tetrahedral. And the best example of tetrahedral is methane. Okay, methane has CH4, so it would be a carbon with equal bonds to the hydrogens. Looking at this, you're like, okay, well, that's as far apart as they go. Well, in 3-dimensional space, it's not. And if it helps you to kind of get a model or something to help you out, it might be good. Or look at page 202 in your book. What it actually looks like is something like this. We have an H here, an H here. Remember that the dash is going into the page, the wedge is coming out, there's another hydrogen, and then one like this. So it's still like a tripod, but now all the hydrogens are as far away from each other as possible. And that's called tetrahedral. Alright, and that bond angle is going to be 109.5. That is why I said that the ammonia would be maybe close to 109.5. Then you have trigonal bipyramidal, and trigonal bipyramidal is when you have trigonal planar, but then you have extra on the top and the bottom, so then you'll have one, it's kind of like this one going back, this one coming out, and it looks sort of like that. And I'll show you examples of these. And then of course this angle would be 120, but then going from top to the equator, that's 90 degrees. So that's trigonal bipyramidal. Okay. Then you have octahedral, and that is where you have all 90-degree angles. So you got some like coming out, going down and back. It's really hard to show this. You're better off probably to look in your book. I could go like this, I guess. You have these coming out of the page, those going back, and then you have some going up and down. And then every angle is 90 degrees. And then you have square planar, and square planar is the same thing as your octahedral, except you don't have the top and bottom. You're going to have electrons there instead, so it's just going to make like, you could draw it in a plane, so it's going to make that perfect square like methane. Or you could do it kind of how I did a second ago and draw two going back, two coming out, and then what you're going to have is electron pairs on the top and the bottom instead. And then the last one is T-shaped. T-shaped is just with a lot of electron pairs. You're going to end up with a T shape like this, and this could mean you have two electron pairs over here on this side, or you could have however many pairs. It could take the octahedral sort of form and have a couple more electrons there, but that's T-shaped, and it really does look like a T. I know that was probably really confusing in a whirlwind. I wanted to try to keep the video short, but I will do a couple videos here in the future showing you examples of each of those